Hi, today we're going to be looking at how to use mash to make a bunch of distributed objects move to and seemingly adhere to another object, or to fill the second object. This could be achieved with particles as well, and the workflow would just be different, but mash offers a certain flexibility that has some appeal. What you'd be giving up are any true dynamic collisions, any collisions at all between objects, so there's nothing to stop these mash objects from striking each other or from going through the object that they're sticking to. So if you need something that allows that sort of control, then particles, the end particles, are what you'd need to turn to. But for now, let's look at mash. And we're going to create an object, something simple for this, just a torus here. I'm going to give it some more divisions because we're going to make things stick to the poly faces. Anyway, it's something like this. And I'm just going to delete its history and freeze its transformations. Now, to do this effect where a bunch of scattered objects move to stick to the surface or to fill an object like this, we actually need two mash networks. But let's start from the beginning where we actually get the effect that we want, having particles or distributed objects stick to this surface. So we'll start with just a cube, and I'll make it pretty small. Maybe that's a little too small. Okay, so something like this. So a tiny cube. I'm going to delete its history and freeze its transformations. And we'll just keep its name as polycube, and we'll select this and go to our mash shelf and just create a mash network. Now, by default, this should be a mash instance, and it is here. We can see in the outliner. It could be a mesh rather than an instance where each one of these has its own shape node, but for us we don't want to do that. So here I've got the mash editor open. There's my mash distribute, and I want to distribute these mash objects onto this surface. And to do this, we can go to the mash distribute node and change it from grid distribution type to a mesh. It's going to tell us we need to connect a mesh, and the mesh we want to connect is the torus, right? So if we open up the options for the mesh distribution, you'll see there's an input mesh here, and if you have your outliner open, you can just middle mouse drag the torus onto that. Now it's hard to see because there are only a few of them. I'm going to change the color of my input object so it's easier to see in our viewport here. My Arnold has disappeared, so let's forget about Arnold right now, and we'll just create a new Lambert and make it bright red. So just hit 6 on the keyboard. Now you can see them distributed on the surface here. There aren't that many of them, so if I go back into my distribute node, you can see I only have 10 here. I change it to 100, there are many more, 1,000, 10,000. Now how are they being distributed over the surface? Well, they're just scattering, and in most cases this can work quite well. If you've got an object that doesn't have evenly distributed polygon faces like this one does, and in fact this one suffers from it a little bit here, you can see the polygon faces in the inside of the torus are smaller, and they're getting a disproportionate number of distributed objects on the surface compared to these big faces here. So what we can do instead is go to the distribute node, and we can say scatter using face area, and that will try to take into effect the size of the faces and distribute them more easily over the surface. So that's pretty good. You can also, instead of scattering in this way, you can do random vertex, face centers, all these sorts of things. But the one that's actually quite different is Voxel, and this will fill the object with these. So if I do that, we can't see anything. If I just go into 4 on my keyboard here, you can see that these are inside distributed evenly around the inside of the torus. So we can go to voxel settings here, and we change the number that are distributed based on the voxel size. So if the voxel size is smaller, you see we'll get more of these things. I'm just going to hide my torus. And now you can see that these things are distributed inside the object. We still have a max voxel count here. Now this can easily crash the machine, so I'm going to turn this off. But you can use this if you want to fill the object. We're just going to scatter on the surface. So we go away from those voxel settings, and we have the torus hidden. That's fine. Let's just keep it hidden. And you can continue to add mash nodes using the mash waiter to this. So if you wanted this to be on the surface but actually animating, you could add a signal. So if we just go here, oh, I need my mash editor back. So if I just play my animation now, you can see they're still trying to stick to the surface, but the mash signal is giving some animation to them. Right now it looks like the signal is doing most of the change in Y. So if I change that, it will keep it evenly distributed in X, Y, and Z. Anyway, so you can do lots of stuff like this. So that's how you can make things stick to an object. And if this, I'm going to actually save this just in case I'm... So now what we want to do is to create another mash network. So let's say we have these just distributed in space. We want them to go to this shape. So we can use our same polycube that we created before, create a new mash network. So this one's called mash2, and we'll distribute this one in a grid, but we'll make it a grid like this. So I'm making a 10 by 10 cube, and so it's got 12 by 12 by 12. I'm back. I went back in and I changed this. I turned the values up too much and Maya just started to slow down on me. So I've given this 10 by 10 by 10, so we've got 1,000 here, and then I changed the instance count to 1,000 here. We want these to match up, have the same distribution number for each mash network. Okay, so this second mash network, I'm going to rename it, so I'll call it cube mash, and this one I'll call torus mash. Okay, not toaster, torus. So the cube mash, if I want to move it up here so it's in the same place as the other one, I can add a transform node, and I can move that up. Something like this, so just to move it into place here. And let's say maybe on the cube mash I want to add a signal. Oops, not 55. Anyway, so you can see they both have a signal, so we can get this random motion happening easily. So now if I select the cube mesh, I can add what's called a merge node, and then we can set the torus mesh as its child. So under the merge node here, there's the parent node and the child node. So I can just middle mouse drag the torus mesh over, and then I can animate the cube mesh transferring its position to that of the torus mesh. So I can hide the torus mesh. So select that instancer, hit H to hide it, and then go back into the merge node. And I can animate, the step strength if I want to have it happen in an orderly fashion, or I can use the random strength. Okay, so what we'll see is the signal node moving this around, and then maybe at this point I can set a key on random strength on the merge node, and then key it down to 0 sometime later. Right, so then it takes the position of those torus instances. And I think I could probably add a spring node here. Let's just see. It might not be that visible because it keeps moving after the fact. I'm going to reduce the damping and stiffness. Did something weird. I'm going to turn off the signal nodes for both of these, just so I can have no movement, and then they'll move together. Yeah, so you can see the spring node at work there. So I can turn up the stiffness and damping a little bit. Okay, that's pretty good. So I can turn the signal back on the cube mesh. Let's see how this works. If I just have it on the cube mesh, so it's moving around, and it merges. And now it's going to be locked to the torus node, so you can see it's ignoring the signal, things like that. So you can have more freedom to control it in its different states. Alright, so we had that spring action, but now it's following the signal of the torus mesh. So this torus is a simple object that I've created here, but it could be any type of object. It could be a rigged character even. So these things could fly to the position of the rigged character and follow it after that. So that's just the merge node using two mesh networks to make it seem like when the instances of a single mesh network is sticking to the surface of another after transferring its position to that. Okay, good luck.